Solutions. A solution is a homogeneous mixture. Most of the solutions we deal with are solutions of something in a liquid, usually water. Water is most always the solvent, since there is usually more water than anything else. All other substances that are present are solutes. We will explore this more in Chapter 13. When ionic solids dissolve in water, they separate into ions. For salt, for example, NaCl, we get separated Na+ and Cl- ions. This process is called dissociation. In water, the polarity of the solvent molecules helps them insulate the ions from each other and keeps them separated. In the solution, the ions are completely independent of each other. Molecular substances do not break into smaller pieces when they dissolve. When methanol, CH3OH, dissolves in water, the particles present are methanol molecules. Electrolytes are substances that dissolve in water to form a solution that conducts electricity. This conduction happens because the substances break into ions. Contrary to what most people think, pure water is not a very good conductor of electricity. Non-electrolytes do not dissociate when they dissolve in water, so their solutions in water do not conduct electricity. There are three general classes of electrolytes: acids, bases, and salts. All ionic substances are electrolytes. These are the salts and the strong bases, group 1 and 2 hydroxides. Molecular substances that are acids are electrolytes. All acids are electrolytes because they dissociate into the hydrogen ion and an anion. Some acids are strong electrolytes, but most are weak electrolytes. Weak bases are also electrolytes because they produce hydroxide ion in water. Molecular substances that are not acids and bases are usually non-electrolytes. A strong electrolyte dissociates completely when dissolved in water. All ionic compounds are strong electrolytes. The strong acids and strong bases are also strong electrolytes. Weak electrolytes do not dissociate completely when dissolved in water. These are molecular substances. The weak acids, the answer to the question, what is a weak acid, is any acid that is not a strong acid. And the weak bases, ammonia, NH3, and its related compounds. On this slide are listed the strong electrolytes. It is extremely important to know the strong electrolytes. You should memorize this list. There are 7 strong acids. They are hydrochloric, HCl, hydrobromic, HBr, hydroiodic, HI, nitric, HNO3, chloric, HClO3, perchloric, HClO4, and the only polyprotic acid, sulfuric, H2SO4. But only the first hydrogen of sulfuric acid is a strong acid. The second hydrogen is a weak acid. The strong bases are hydroxides of group 1 metals, alkali metals, and hydroxides of group 2 metals, alkaline earth metals. Salts are ionic compounds that dissociate into ions in water solution, whether soluble or not. You should pause the video here to write down these strong electrolytes. When you mix solutions of ionic compounds, the separate ions can freely mix with each other. If any of the resulting new combinations are not soluble, a precipitate results. This is a solid that comes out of solution. The solubility can be determined from a standard set of solubility rules or guidelines that summarize what we know about the solubilities of ionic compounds. One such set of rules is summarized on this slide. It is extremely important that you know these rules. You may pause the video here to write down the solubility rules. Here are a couple of suggestions for learning the patterns. 1. Learn the few ions that are always soluble. Any compound containing any of these ions will be soluble. 2. Learn the big three: silver, lead-2, and mercury-1, and the little three: barium, strontium, and calcium, that are nearly always not soluble. 3. Learn the anions that are nearly always not soluble: carbonate, sulfide, phosphate, and hydroxide ions. We now return to types of reactions. We have already learned 3 types: synthesis, or combination, decomposition, and combustion. The 4th type of reaction is a metathesis reaction, from the Greek word that means to transpose or exchange. It is sometimes called a double replacement reaction. This type of reaction always involves 2 soluble ionic substances, like silver nitrate and potassium chloride, as shown in the reaction. The ions of one substance pair up with the oppositely charged ion of the other substance. In this case, the silver ion in the first compound is positively charged, and the chloride ion in the second compound is negatively charged. When the reaction happens, it appears as though the substances exchange ions, so the silver ion is matched with the chloride ion. Metathesis reactions will often produce precipitates. Other possible products are weak electrolytes and non-electrolytes. When we are doing solution reactions, it is important to focus on the species that are actually present in the reaction mixture. This means that, for dissolved ionic substances, we should focus on the ions rather than on the molecular form of the reaction. This will enable us to see the species that are actually reacting during the reaction, and ignore those things that are present, like water, usually, but are not actually changing during the reaction. We can then better understand the patterns of reactivity that we see. When we have an equation that only shows the things that are really changing in the reaction, we have what is called a net ionic equation for the reaction. The most obvious way to write one of these reactions is to start with the molecular equation. The molecular equation lists the reactants and products in their molecular form. If these are ionic substances dissolved in water, this is not the way the substances are actually present. In the ionic equation, all strong electrolytes, strong acids, strong bases, and soluble ionic salts are dissociated into their ions. Silver nitrate, potassium chloride and potassium nitrate are all dissolved, while the silver chloride is not. So we should write the reaction like this. This more accurately reflects the species that are found in the reaction mixture. To form the net ionic equation, cross out anything that does not change from the left side of the equation to the right. In this case, the nitrate ions and the potassium ions do not change, so they are crossed out. The only things left in the equation are those things that change, that is, they react, during the course of the reaction. In this case, the silver ions and the chloride ions combine to make a precipitate. The ions that are crossed out are called spectator ions. The general principle is that spectator ions do not get written in the reaction. This slide summarizes the steps to make the net ionic equation. They are: 1. Write a balanced molecular equation. 2. Dissociate all strong electrolytes. 3. Cross out anything that remains unchanged from the left side to the right side of the equation. And 4. Write the net ionic equation with the species that remain. You may pause the video here if you need to write down the steps.